So this is a video to help you fill out the spreadsheet that's part of the final report on the passive design model and its digital twin. I'm going to try to be succinct here, but at the same time, I may go down roads of explaining things. So remember, you can speed it up. You can scroll through to find what you need. Okay, so first of all, to access this spreadsheet, you need to go to the final report, which is now an assignment. Read all the instructions closely, of course, and then you need to download this spreadsheet. If you open it up in Excel on the web app, it may look like this, not formatted in the same way. That's a lesson, or the reason I'm showing you that is because you know this is a resource you're being given. You're just filling in cells and it's automated. So it's up to you though to make sure it's formatted correctly. So in other words, because of your screen resolution, it looks different, you need to then adjust it so that you're not turning in a spreadsheet that has cells, has information in cells that can't be read because they're overlapping or whatever. So just stop, be an architect, say, what does this look like I need it to look, and adjust it if it doesn't. To do that, this will come to you as a protected sheet. I just protected it because I'd unprotected it before, which means I've set it up to where you can input values in the light gray and blue cells, but you can't access any of the orange cells and some of the other a lot of the labeled cells I've closed too. If you need to adjust, so now if I want to adjust the size of a row or a column, I can't do it. So if I need to adjust the formatting, I can unprotect the sheet and do whatever I want to with it. Okay, so this spreadsheet has changed a little bit since you saw it in class on Thursday. One thing I added was this section here, and that's because, so let's remind ourselves quickly, we live in the United States, we're still using inch pound for some reason, everybody else uses metric, but we need to navigate both. I'm trying to get you to use IP in all cases, except I decided to make lux our value for daylight because it just seems like that's what we've switched to. If you look at light bulbs at Home Depot, it probably says lux now. It probably says watts on the front, but then if you look at, there'll be lumens and lux values. So anyway, it's going to be like this in your career. You just have to keep up with whatever it is people are using and understand what that means for you. So in this case, the sensor that we used in Old Westbury, the one that I walked around with, or Serena and I walked around with and measured people's solar irradiance values, measured in watts per meter squared. If you used your cell phone app like that Pyranometer on the iPhone, it's probably also watts per meter squared. So that just means we need to convert. So I've set up an automated conversion. So I put in a number here, and it automatically will populate the correct cell there. So you're going to need to go back and change your inputs from what you did in class. This is a simple calculation. It's just the value times 0.317, the watts per meter squared. So you could do this yourself if you wanted to, but I've automated it. Remember, you're filling in the light gray, which is for the exterior, and the blue cells, which I'm saying are the interior, or for the interior. All the orange cells have calculations in them so that you're not accessing them. So I'm trying to make this automated. I also have added some baseline temperature and relative humidity data from, I went to Weather Underground. They have a historical data page there, and I looked it up for the closest site I could find, which is Farmingdale. I took the data from there. I then I accessed our Ed Hall weather station data, which this link just goes to the value for today or for yesterday. So that's what I was using then. If you wanted to check it, you have to find the link on the website, on the library website that takes you to the historical data. Anyway, and then I had one of our Govee sensors outside in the shade when we started the exercise, and then I thought, oh, let me put it in the sun. So I just it's the same sensor. I moved it from the shade to the sun. The point here is that these values are fairly different. Especially this relative humidity, I need to even go check it again. Seems quite high compared to but this is in a completely different place. This is in a very similar place, but a very different sensor. Um, so, you know, we have to just realize that uh, we have to decide for ourselves how important it is to be accurate in what we're doing, and then access the accurate information. Okay, I think the rest of this is the same as described in these drop downs, these comments. So I've tried to annotate this very clearly. So let's move on to the digital model side. And if you have any questions about any of this, you can email me regardless of what section you're in. Okay, so remember that the concept behind this this is a data portion of a layout that I'm asking you to do, or that we're asking you to do, as a summary for the exercise portion. We did theory and design concepts in the first half of every week, and then we did a practical hands-on exercise in the second half. This is the summary for that. So you not only bring in these two data sets from the physical and the digital, you need to have photos of the actual, I didn't make my own cube, but, this is what you did. And some of them they were all awesome. It was really fun to see you guys out there experimenting with these with the cube models. So we need pictures of the two iterations. Remember that the idea here is that we have a baseline and an iterated design, or just an iteration. Those are two iterations: a baseline iteration and a second iteration. So we're not saying that there has to be any specific difference between the two. They just have to change, and we're comparing the two, right? And then we're doing that both in the physical side and the digital side. So whatever we're physically modeling, we need to have digital models of. Actually, it was the other way around. We were digitally modeling and then deciding what to do physically to see if we could get a correlation, or just to because that's the way we'd actually do it in a architectural context. Anyway, so that's what the reason I went through all that is to say that then this is 10% of your grade. We've taken out the assignment where you have to do where you were going to take your studio project and retrofit it using passive design principles. And I've also lowered the value of the final to 15%. So now it's the same as the midterm, because I wanted to give you a little bit of time to do this. This is something that if you've done the exercises, you should have all this information already. If you haven't, you can just redo them, or even if you have, you can redo them based on what you've what you decided in terms of the actual physical models you used. It shouldn't be onerous, but I wanted you to have a little bit of time, and so free you up from some of the other things to do this. Okay, so that's the background of that. Let's now look at the digital side of the model. I did these exercises so that I would have something to put in the assignments. So I'm just using those here. So I'm just a reminder, right? We have our drop down in Climate Studio. Let me turn this off here. And we can always look at the sun path very quickly. Turn on our the annual sun shading pattern, and then move to other simulations. So that's what we've been doing all semester. I created some layer states so that I could easily move between my simulations. I also fairly meticulously, well, not meticulously, but I organized my model so that I had access to different simulation runs. I would imagine most of you didn't do this, even though I talked about it in class. I'm just always advocating, trying to get you guys to be more organized, because it's really the only way that this is practical to do this kind of digital twin, or these digital studies of whatever we're designing, so we can get inputs that will help us, or get information that will help us decide if we're going in the right direction and what we need to change. All right. Anyway, so let's look at our spreadsheet. The first thing we're asking for is the solar heat So there's solar irradiance, I'm calling it solar heat to simplify it, in December, and kBTUs per square foot. So yeah, the first thing just as a reminder, we're not doing apples to apples comparisons here. When we used our sensors out there on Thursday, that was instantaneous, right? We're seeing how much energy is hitting this the surface that we've got our sensor sitting on at a moment in time. What we're doing in the digital model is we're measuring it over time. We can get down to, in the case of radiation maps, a monthly estimate of the amount of radiation we would receive. So it's not like we're saying, oh, did we have the same amount that we measured? They're both interesting and useful pieces of information about the same topic, the same design. All right, so how do we get this data out of here, though? So I'll let you read these comments yourself, but the point is, the summary is, I've got ground, all the facades, north, south, east, and west, and roof that I need to get measurements for. I'll start with the ground. I ran just to remind us, we had a model that had, let me get back to this. Actually, I'll just do a ghosted. We had a model that had a ground. We had, and then we had our cube in it. So let me go to that. And we had, if we had placed our model in a place where there was shade, we were modeling that. And so I have all those runs from that exercise. Let's just go look at them again just to remind ourselves. I have a cube. I have it with the shading, so that would be with this shading, and then this is with this shading, right? So the point being that we're estimating different amounts of solar irradiance on our cube based on different changes that we're setting in the model. I started with just the grade, and that's our first. Remember, we can change our range down here. It's really important that you have, when you're doing screenshots for this, that you include the range and the units that you're using. Make sure that you're in IP, not metric. One place to change that is back here at the globe where we have our climate data, IP and metric. Just you got to be conscious of what those kind of details, which of course, if we have the wrong units, the information is completely useless if we don't realize that and convert it. Okay, so I'm saying I want the solar heat in kBTUs per square foot. Actually, I need to go change that to and I think I say in here, December, so that means per month, or in that month for the ground. And so I ran a simulation of just something that's sitting on the ground. If I now mouse over and select one of these sensors and come to my radiation map. Now, by the way, just as a reminder, sometimes you're not going to see this because there are these overlapping pull down graphic windows in Climate Studio. So just make sure, don't feel dumb if you can't find it. It happens to all of us, but it is there. You just need to find the pull down. Okay, so in December on this at that sensor. We have 16, by the way, since it's just the ground, there's no shading, it's going to be pretty much the same for any sensor here because they're not changing. We have 16 kBTUs per square foot, so I'm going to put that in for December. And if I go to June, we have 60. Okay, simple. Now let me go to look at my cube model. I like the third. Just choose the graphic that you want and stick with it. Also, remember that again, always including the range, but also choose a range that if you're showing 4 or 5 radiation maps of different to make comparisons, you need to make sure the range is the same for all of them so that the colors are the same. So you can change that at any time after you've run these. So it could be something that as you're making your graphics, you choose, but just be conscious of it. Okay, so now I'm in my south. If I mouse over one of these, and these are again going to be fairly similar. If I have a ground here that I didn't in this case have a larger ground that I ran, I guess maybe I should say even that I should do that, but that's just a choice. This is cleaner, but it would probably then make it. I would have a little bit different amounts down here than I have up higher because I'd have some reflectance off the ground. But anyway, so I'm just going to select one of these sensors in the middle of my wall and mouse over December. I've got 29 December in the south, and then in June I've got 25. Okay, so first, right there, there's interesting information. We have a lot more sun on the ground in the summer, and a lot less in the winter, um, as would make sense based on our understanding of how the sun moves through the sky. Um, but then on the south side, we actually have more sun in December than we do in June. Um, so, oh yeah, that's what we've learned about that. How the south side is a place that we can focus on um, collecting solar heat if we want to, because that's well. Let's just keep going, and let's do one more. So on the north side, the west side, um, I've got 13 in December and 33 in June. And so we have, you see, we have the opposite. We have um, more sun on that facade in the summer when maybe we wouldn't want it, and we have less in the winter when maybe we would want it. So the dynamic between the ground and the south facade and the west facade is very clear here. All right, so then you would continue that, and you do that for both your baseline and your iteration. Very possible that the iteration is going to be the same. I'm going to fix this for the exterior, but it might not be because it's according to how you built your model. If you have any context, it would change. Okay, so then we have to. The next thing we want to do is measure or see what the simulation says about for our baseline model what the amount of sun hitting the floor close to the south wall. I just chose 2 data points, and then the center of the floor. So I've got a simulation. So first of all, you have to choose, and you should have done that at the beginning of the assignment, but I'm just talking about it now because I'm just quickly blasting through this. We have to choose what our baseline is and what our iteration is, or our iterated model. So I'm going to say that I'm going to call this my baseline. It's my cube with a fairly large south-facing piece of glass. And then, and, okay, I'm not going to talk about how to set up the simulations. These are all things we've done. Go back and let's just remind ourselves. If I go to Canvas, all of the exercises that everything that I'm talking about here has been done in one of these assignments, and there's instructions and often videos that are supporting it. So you can go back and review if you haven't done this yet and you need to refresh yourself. Okay, so near the south side in December, I've got 14. Oh wait, I'm sorry. In my baseline, I have 14 kilobtts per square foot, and then in the middle I can say 165, 2, whatever I want to say for the. I could even go between the two since I've seen 165 and 202. Let me say 180 right in the center, and anyway. Sorry, that's this. And then if I go to June for sometimes it's hard to access these when we have the geometry on. So I can also just turn it off. Let's say it's 389. Wait, that's wrong. It's going to be 14. No, I'm sorry, June 40. And Oh, I realized I screwed up on the other one. Sorry about that. 40 and 5. So let me go back and redo this. Um, all right. I totally just confused all this. I'm going too quickly. Let's do this again. On the south side of the building, in December I have 14, and in June I have 40. So 14 and 40. In the center, I have, I'm just going to call it this one, 13 and 7. So 13 and 7. So interesting, right? In our baseline, we're saying that um, in the center and the south, it's almost the same in December, but a big difference in June, which is the summer when it's hot. So we're hopefully reinforcing things we might have already known from the theory and from looking at the path of the sun, but we actually have actual data points here where we can do quantitative comparisons, and we're also both reminding ourselves about the fundamentals, but also proving them to ourselves, and then getting deeper into the specifics of how they would work. That's the idea behind this. And then we would do the same thing for whatever the iterated version would be. And I'm not even going to decide that here. I've got different. I go back to. So I had different. Let's see how I iterated the. I did just really lame. Yeah, I had different shadings that I tried. And so I would have to turn those on, run different simulations, and got different inputs for the iterated version. Okay, so let's move on to daylight. We did, and so I'm just saying that. Let me go to just a baseline layer for that. So when I ran this baseline in the daylighting, I got an average of 7,000 lux. But let me go to, by the way, so this is where you're going to be when you start, if you run your simulation. Remember, we haven't talked about these. Ignore all these other tabs here. We're just looking at the average lux. We know what lux is. It's the amount of light hitting a surface. And you'll see, and by the way, we're in IP units here, and they're calling it lux also. So I mean, this just seems to be the way we're going. Not using IP units for illumination, but here, this is an annual average for this space with the where these sensors are set. I'm going to go into the specific day, and I had already scrolled over here. You can scroll around. You can go to the actual day that we're talking about. Set your time. Now, this is a simulation coming from climate data. It's going to be averaged, and there's times when there are going to be clouds put into the sim. Anyway, it's averaged over a period of time. It's not going to be exactly the same, but we see that. I mean, at least from my experience, these were values. And we should do one on the exterior. I didn't do an exterior surface. These are very similar to what I was seeing with the sensor we were using outside. So that's interesting, and as it says it should be, but it's a huge amount of light, right? We're saying that if we're sitting at a table trying to read, or we're at a desk, we'd want maybe 500 lux, not 27,000. So what I found in my playing around with this really quickly was that I had to create a very different. The only way I could get anywhere near the daylighting, a reasonable amount of daylight, was I set my glazing. I had a small piece of glass up high, and I added a light shelf inside. And when I did that, let me see if I can find that quickly. Okay, that's all shade. Daylight, blinds, header on. Oh, here it is, light shelf. See, now my average. Oh, and by the way, that was ridiculous. I should have had this at, let's say, for that. Well, let's just put this at 1,000. So if I go back to my original run, which was this one, um, I can go up to 30,000 here, and it's not going to be, okay. I can see at 30,000. I can see what's actually going on in terms of. Remember, this is with the full piece of glass. Um, so in this case, it's going to be hard to if you actually did this. I don't think anybody did, but if you tried to get anybody that I saw, if you're trying to get a daylighting design that would actually give you in this little tiny space a reasonable amount of daylight in there, you'd have a drastically different amount of daylight than you did in the baseline, and so you'd probably have to use a different range. So anyway, let me go to that. It's just going to be, since we're at 28,000, 1,000 is the max, is always going to be red, but then it does allow me to come to my iterated. But then I can see gradation here that makes some sense. Make sure this is, yeah. And look at the drastic difference now. So we have an average lux of 214 on the day in question. We actually these are reasonable amounts. Here in the middle, I've got 700. By the south side, 400. This 750 at the back. So this would be you could read a book in there and it wouldn't be uncomfortable. Remember, this is an 8 by 8 foot room. Anyway, so what I would be doing here is I'm going to go back to my. Well, actually, I'll do the iterated design here. So I'm saying I want the average for I actually didn't say this should be the average for the day. But if you do, you could do whatever makes sense to you. I'm going to do the average for the day. Well, actually, I don't have access to the average for the day. This is the annual amount. So I'm going to say the average. Yeah, I think this is what I was trying to say. So the average here is 214. The high. Now, I'm not even really sure what I want you to do here. Yeah, okay. I guess. No, I'm going to say this. I want you to have the. I'll go adjust this. I want to have the annual average, and then. And these should actually all be interior, so I'm going to make these all blue. I'm going to have to edit this. This is a work in progress, as you can tell. And this is the wrong blue. I'm going to change it again. Okay, so here on the fly, I'm going to say that we're talking about it's all for this day. You have to. So the point here was you have to decide what. I wonder if I should do that. Because if you think about it, the daylight for the year doesn't really give us that much information for the same reason we were talking about before, because it's going to change quite a bit based on the season. Okay, I paused to think about this, and I think this makes more sense, and this is what I was saying. We're going to use the annual average. So in this case, I've got it back on the annual. It's 214 for the average. I'm looking around for a high, so wherever I'm seeing a different color. I could change this. Maybe this needs to be, if I want to see more of it, whatever. I think it should, let's just leave it at that. So I'm going to say 350 is the high. And again, this is the high for an average. And the low average, probably, let's say 108. Now, we need to go to the specific day. I'm going to say it was 11:30, and I'm going to say it's the middle of the space for that day. So this is what we'd be then comparing to the middle of our space, whatever the number was we got over here. The instructions here is you're putting the sensor inside. This could vary quite a bit, and I noticed because of where if you have a complex lighting pattern. If the sensor is in the sun inside, it will be a high lux, and if you happen to have shade on it, it won't. So we could have been more nuanced about that, but I think this is enough. I think everybody would agree. All right, and I'll make a notation here saying this is the center of the room. Okay, so just as a review, annual average, annual high, annual low, and then whatever time that you took your measurement outside, what is uh, the lux simulated lux value in the center of the room? All right, and so then the final, well, no, the final category of data that we need is for energy use, and here we did that energy simulation starting a couple weeks ago. Let's go to that. Let's just be graphically clear. And I'll switch this. So I have a baseline simulation. I think actually, so this is the way I notate these simulations. I'm saying that this little icon here means it's a thermal analysis. So I'm calling this envelope because that was the assignment. PB is particle board, so my envelope is just particle board. I have an infiltration set at that's the amount of air leakage at 0.2. There's a long video on this that I think it's an hour long, 50 minutes long. So I'm not going to go back over all that. Just remember to go if this is still not clear to you, check that video out. I've got default glazing, and I've got a window-to-wall ratio of 0.4 in this. You can see that's different here. I think I'll just go change that so that we at least initially have a consistent. I paused again to troubleshoot for a second. I was trying to change to my window to wall ratio, that automatic setting, and the reason it wasn't letting me do it is because I had my actual glazing turned on, because I actually applied glazing, and so when I turn that off, it lets me go back to the 0.4. I'm not asking you to get into a lot of detail here. Every semester we're gonna add a little bit more skill in terms of our simulation abilities. But and one reason why I have these detailed descriptions here is because let's go to a daylighting run, and you can see here so this is we're accessing daylighting runs, even though I'm seeing another point just to always make is that what we're seeing in the graphics window is not necessarily what the simulation results are showing. Sometimes it updates that, other times it's just showing us a generic whatever we have on in terms of layers. Anyway, if I'm in most of the other simulation types, like daylighting, there's a little information icon here. I can click on that and see what layers I had on in that simulation. That's very helpful. You don't have that in the thermal analysis versions. You have a lot of data here that you can download. It's a little bit complicated, and it's not really worth doing for this. So that's why I make these more detailed in my description, so that I can just remember what I changed. Okay, so the point is, we're coming back, and I have these two. I added a column here, so now this looks a little bit complicated. For now, I'm just going to merge these two. Actually, what I'll do, I'll just show you some quick editing of a. This I'll make, I guess, gray. I might change that up when I finish this video. But the point was, I added a cell here because I'm in a column, because initially I only had one measurement for the interior, and I didn't think that was good enough. I wanted to have something by the south and something in the center. And so then that's one. I don't know if anybody's really going to ever try to emulate the kind of layouts I do in Excel. But one clunky thing about it is that when you change it, since it's modular, when you change something, it often screws other things up, and you got to go and do stuff like I'm doing right now. Um, and when somebody shows me a better program for this, I'll be happy to use it. It's just this one has such staying power. It's been my entire career, and well before my career, Excel was sort of the default, and it still seems to be. And so I, as an architect, have tried to make it useful graphically. Okay. Anyway, so what we're saying here is I have two inputs that I'm asking for your baseline and your iterated, solid and glazed. I'm just asking that you run a simulation without any glazing. Get the output. That EUI value would go in there, and then whatever your baseline iterated glazing is, that's what's being used in the calculations that we're actually comparing. So then if I came back and I'll just put the 0.4 in again. Remember, and I've showed this in the video, you can go to directional here and make these any combination that you want. We'll see it. Actually, this is the one we'll see in this view. So I'm changing the amount of glazing. It's just a ratio, so it's not setting it someplace. It wouldn't be good to like try to estimate daylighting because, well, anyway, the point is it's a quick way of changing your glazing, and you're welcome to use this. Okay, so if I go to my results, what I'm saying is that and I don't even know if I did this in these actual simulations. I've got it, so I don't have anything that's without the glazing, I don't think. So right now I don't have anything to put in here. So my default, and I did a window to wall ratio of 0.4, which would be, let's go back and make this consistent with what I'm showing you. I ran this essentially and got this value, and so I would put the 515 here. And remember, this is the amount of energy we're estimating that the project would use per year. I don't know why I wrote 514. And then whatever iterated version I did, let's see, find something. I have one where I've insulated it. Actually, this is probably more closer to what you guys were doing. I have one that's just glazing on the south only, so that would look like this. And for that one, my value was 301 for my energy use intensity per square foot. And then for, let's say I think that might be already the insulated version. Let me see. Yeah. So I don't really have a good example of this right now that I'm going to quickly put up. But I mean, so there would be one that's for your optimized. I know I have things that are much better here. They're just doing different things that I want to talk about. So I could, maybe my optimized would be 344. And we can see that since I've filled out some stuff here, that we're getting these automated outputs that will be part of your ability to analyze, say something intelligent about the difference between the iterations and the difference between the physical and the digital model. All of that is described in the assignment itself, so make sure you read that. Okay, so that in a somewhat roundabout way is my description of how you should use this spreadsheet. I'm just looking at it again to see if there's anything that I've missed. I'll clean up anything in here that I discovered through making the video, and I think we're good to go. Again, I know that I'm the one that's creating this, and so even if you're not in my section, you're welcome to email me with questions. And I hope you'll put some effort into this. And once you've done everything, you've put in the values. The whole idea behind this is to compare it, to think of what we've learned about, look at the data, and make some intelligent brief simple comments about what you see. All right. See you next semester. No, we'll see some of you at the final.